Okay, let's do the ninth question. Okay, the ninth question is prove that tan inverse root x is equal to 1 by 2 cos inverse 1 minus x whole divided by 1 plus x. Okay, where x belongs to the range 0 to 1, close interval 0 to 1. Okay, so now when we look, we have to prove that this is equal to this. Okay, so now when we look at this expression, this whole thing, or at this particular expression 1 minus x by 1 plus x, if we look at this, if this was some, say this was some cos theta, then we have cos inverse cos theta, the property of cos inverse cos theta. Okay, this will resemble the property that is cos inverse cos theta, which is equal to theta if this theta belongs to the range of cos inverse 0 to pi. Okay, okay, so we'll try to make this expression or convert it to some cos theta and see whether it works or not. Okay, so let's take the right hand side and prove. Okay, that is RHS. Let's take the right hand side now. That is 1 by 2 cos inverse 1 minus x whole divided by 1 plus x. Okay, now again, if you see this expression, this 1 minus x by 1 plus x, this resembles a trigonometric formula, that is cos 2 theta is equal to 1 minus tan square theta whole divided by 1 plus tan square theta. Okay, so if we change x to tan square theta, if we put x instead of x, if we put tan square theta, or take the value of x as tan square theta, then we'll have 1 minus tan square theta and 1 plus tan square theta, which will be resulting this formula. Okay, so now let's take that and see. Okay, let's put the value of x as tan square theta. Now, so let's take x is equal to tan square theta. Okay, so 1 by 2 cos inverse 1 minus, so x is equal to tan square theta, so let's put tan square theta whole divided by 1 plus tan square theta. Okay, so this can be now written as cos 2 theta. Okay, so 1 by 2 cos inverse cos 2 theta. Okay, now according to the property cos inverse cos theta is equal to theta if it exists or belongs to the range. Okay, so cos inverse cos 2 theta should be 2 theta only if it exists in the range. Okay, so let's take this separately and try solve it. Okay, cos inverse cos 2 theta equal to 2 theta if 2 theta belongs to the range of the cos inverse 0 to pi. Okay, so let's see that. So now they have given a condition x belongs to 0 to 1, close interval. So let's take that condition, x belongs to 0 to 1, close interval. Okay, now this can be written as x less than equal to 1 is greater than equal to 0. Okay, now we have taken x is equal to tan square theta, so let's put tan square theta instead of x. Tan square theta less than equal to 1, which is greater than equal to 0. Okay, so now we have to find out 2 theta. Okay, whether it exists or not, so we have to take out theta. So let's take first tan theta. Tan theta greater than equal to, now square will go here, greater than equal to root 0. Okay, now this is 0, tan theta less than equal to root 1 is 1. Okay, now we have to take out theta, so theta less than equal to tan inverse 1. Okay, and greater than equal to tan inverse 0. Okay, now we know that tan inverse 1, the principal value of 1 tan inverse 1 is pi by 4, okay, and for this tan inverse 0 is 0. So we'll write this as, we'll write it here, tan inverse 0 less than equal to theta less than equal to tan inverse 1. So tan inverse 0 is 0 less than equal to theta less than equal to tan inverse 1 is pi by 4. Okay, now we have to prove 2 theta. Okay, so we have to find out whether 2 theta belongs to the range. Okay, so let's multiply it with 2 theta by 2. Okay, 0, 2 multiplied by 0 less than equal to 2 multiplied by pi by 4. Now 2 times, and this becomes 0. So 0 less than equal to 2 theta less than equal to pi by 2. Okay, now we have, now our 2 theta is in the range of 0 to pi by 2. So we can write 2 theta belongs to 0 to pi by 2 close interval. Now if you see cos inverse cos theta, the range is 0 to pi. That is, you see the in circle, this is 0 and this is pi. So this is the range of cos inverse. But here 2 theta is from 0 to pi by 2. This is the range where 2 theta is. Okay, this is the range where 2 theta belongs. So this is inside the range of the cos inverse. So we can say that 2 theta also belongs to the range of cos inverse. Okay, and or we can say that 2 theta is a subset of the of this range. Okay, so we can write, so we can say that 2 theta belongs to, okay, 2 theta belongs to 0 to pi by 2, and also is a subset of 0 to pi. Or we can say directly, we can write 2 theta belongs to 0 to pi. Okay, because it is inside the range of the cos inverse. So we can say that cos inverse cos 2 theta is equal to 2 theta. Okay, therefore since this is the range, we can say that cos inverse cos 2 theta equal to 2 theta. So now here in this instead of this we can put 2 theta here, because this is equal to 2 theta. So we can write 1 by 2 into 2 theta. Okay, so this 2 and 2 get cancelled, you have theta. Okay, now we have taken x is equal to tan square theta. We have taken x is equal to tan square theta. So tan theta will be root over x, and theta will be tan inverse root x. Okay, theta is equal to tan inverse root x. So now instead of theta we can put tan inverse x. So theta equal to tan inverse root x. Okay, so now we have proved that by taking the RHS, we have proved it that theta is tan inverse x, which is the left hand side, which we have to prove. Okay, so this is equal to the left hand side. Prove. That's it.